Hello everyone, this is Yılmaz Yörü, Embarcadero MVP. This presentation is about creating and using 3D objects in C++ Builder. Actually, we're going to show how to use T-Mesh in 3 dimension. And what we're gonna do here is we're gonna draw two-dimensional object, and we're gonna spin this by generating, and we will create a three-dimensional object. Before this, I'm going to show some information. In docwiki.embarcadero.com, you can see details about T-Mesh. It's also detailed in help. If you press help and type T-Mesh, you can see those informations, and there are some explanations and examples. Also, there are sources about how to create three-dimensional objects in FireMonkey and C++, visualizing mathematical functions by generating custom meshes using FireMonkey and C++ by Anders Olsen. And there's also another article in Delphi language. Okay, let's see how a 3D plane placed in a space, in three-dimensional space. There are points P0, P1, P2, and P3, and P0, P1, and P2 is one three rectangular area, and each point has X, Y, Z coordinates, and there are indices. Three indices of this rectangle is P0, P2, P1, and another three indices of this rectangle is P0, P3, and P2. So for this plane, we have 4 points and 6 indices. And how we use mesh in C++ Builder? Actually, we should create new T-Mesh by the owner of form 1. T-Mesh, asterisk mesh, like this. And then we should define the parent of this mesh, maybe do-me1, or maybe any object, a parent object, or ViewPort 3D you can define here. After that, we should clean the mesh data, if there's something, and we should define number of vertex buffer length by 4 multiplying number of planes, and index buffer length is equal to 6 multiplying number of planes. After defining mesh data, at the end, if we don't use this mesh at the end of the program, when you close or when you don't use, you should free the mesh from the memory. Also, you can use material, T-color material source, light material source, or texture material, and then you can change the color of this material, and you define the mesh material source is equal to this material. If you finish using this 3D object and material, you can free the material free like this. Now, after this small presentation, I'm going to show how to do this in a new project. This is RAD Studio 10.3. Now we're going to create file new multi-device application in C++ Builder, so we can run this demo on Android, iOS, and Windows. We will create a blank application. In this example, we're gonna run this example on Windows 32-bit, and what we're gonna do here, we're gonna create an interface. Before everything, maybe we should save this project, save the unit to the desktop, create new folder, creating 3D, creating 3D unit 1, creating 3D project 1 and projects file. Now we're gonna add group box and let's make it bigger, and we will use ViewPort for 3D objects, and we will make it to client and change margins to 10, something like this, and let's change the group text. Now we have viewport, and we can add any 3D objects. 3D objects are shown in palette as here. You can add the camera, light, dummy objects. We need a dummy object here. So when we rotate this dummy object, every object connected to this dummy will rotate together. Also you can add 3D shapes from here, T-cube, T-sphere, cylinder. For the demo, let's add a T-cube here and make dummy 1 parent of this cube. And so, for example, let's change its position to 4.4.2, something like this. We have dummy 1 here, we have cube here. Let's rotate dummy 1 with the timer. And change interval to 36. Double click on it. And let's add some rotation here with dummy 1 rotation angle. As you see, there's pop-up opening. Angle Y. And let's change another dummy 1 rotation. Now let's see how it works. As you see, we have 3D dummy 1 and we have 3D cube, and it's rotating with this. We can also add material source here. Color material, texture material, light material. And we can also add light to this place somewhere around here maybe. This will not the main parent of the dummy. It will be in the main ViewPort 3D. And we will add camera. And let's move camera to the little bit far, something like this, and let's change viewport 3D using design camera files, because we have camera 1. Now we can use camera 1 as shown here. It's automatically detected. If you have more than one camera, you can change from here. Now we have color material, but we didn't define on this. let's make color material cube is this one, and maybe we can move this to here to understand better which color material is dependent. And also we can change the color, something maybe like this, maybe blue, a little bit darker. Okay, now let's run our simplified object. As you see, it's very small because camera is very far away. We are using now camera, color material, source, and we have light. If you want to use light details, you should use light material source. Or you can add 3D model, and you can load any 3D models with the LC form, dia form, and object form. For example, let's load this object. Sometimes if your object is very big, that might take time to load. This is cool. Okay. Now we can change its size. And we can rotate any size. So you can use any 3D object with this model 3D form. Let's delete this, we don't need this. And also there's mesh object. We can directly put this mesh object and operate on it, but we're going to create this mesh object on C++ builder. Now let's start coding again. Let's define mouse down is equal to 0, and line number n is equal to 0, and mouse x 0, and mouse y 0, and we will have number of steps to draw 3D objects. Let's make it 36, and now let's create key mesh pointer. And let's create the bitmap as a BMP, and let's define two-dimensional points, and 100 is enough. And when we create form, let's resize the bitmap. Image 1, local right, and image 1, also let's clear this bitmap by the clear function, FF for alpha, red, green, blue, or you can use CLA white or any colors like this. Also we had a bitmap pointer. Now let's create bitmap on the memory, T bitmap image1 bitmap with image1 bitmap 8. Okay, if we need anything we will back here. Now let's make change here. This wrap mode of the image will be original because we want this original at the same size, at the same pixels here when we drawing. And let's go to events, and when we press mouse down, M down will be 0 and x0 will be equal to current pointer x, and y0 will be equal to current pointer y direction coordinate. And let's add a number because we're going to use the 0 point as a default, and pn x is equal to x division maybe 10. We scale the points and we are recording the point to the as a pn is equal to y10, and we will also copy this bitmap sign from image1 bitmap, and when we are moving mouse, let's use switch to check mouse down option, which state is here, case 1, image1 bitmap sign BMP. We copy the background when we pressed, and now we can draw a line on this. To do this, we will use canvas of this bitmap, and let's copy this. We're going to use this. Let's begin scan. And stroke, let's change the stroke color to the CLA green, and stroke thickness 1.0, and now we can draw line by the draw line command. In this draw line command we should define points, point mx0 and my0 from this point to this point, x and y, with the opacity 1.0. Now we can end scan here. Let's break. We can add default case. I will bring this empty now. Okay. We also need a clear function. When we press clear, will be 0 and image 1 bitmap will be cleared with the color white. Okay, and let's m down set to 0 again. Let's check when we press mouse down, m down will be 1, and when we clear, m down will be 0. If m down 1, this case will happen. And also let's check here. I think it should be like this. Now let's run. If there's any errors. Okay, now as you see, when I press, it starts drawing. There is a background copying every time, and when I press again, it copies this background, and I can draw this new line on this background. Now we have two-dimensional drawing. Let's start generating 3D object. To do this, first we should define t-points 3D, P0, P1, P2, and P3. And let's define number of points and number of indices. Both of them are 0. And let's define I here also. And float degree. And let's define float increments here. And number of steps are from edit 1 text to int. And then we should calculate increment now. Increment will be to multiply MP division number of steps. Let's set m down 0 here, and we will generate mesh, but if there's a mesh, we will free first, and then we will add mesh like this, new t mesh. Now we need owner. Owner will be form1, and mesh parent will be equal to me1, and mesh width will be 1 mesh. I think we will use this, so 8 will be 1, and then let's change this position mesh. Position x is equal to 0, mesh position y is equal to 0, and mesh position z is equal to 0, and mesh again, let's change the scale to 1, x is equal to 1, and mesh scale we can also set the mesh rotation angle. And we can also change the rotation center of the mesh like this, x, y, z. Now we can set the mesh wrap mode also, and t mesh wrap mode class as original, and if this mesh will be two-sided, you should set two-side option true. Let's make it true. But if you have a lot of objects and you don't need it, you should choose this wisely. Mesh visible, let's make it visible now, and let's make opacity, set this to 1.0. Now we can add mesh data. Before this, let's clear data if there's something here. Mesh data. Let's set vertex buffer length. Length is equal to, we have 4 points, multiply number of lines that we draw, multiply number of steps that we're gonna rotate. And again, mesh data. Now index buffer, length is equal to 4. This time we have 6 indices, so 6 indices multiply number of lines, multiply number of steps. Okay. And now we can do for next to spin this two-dimensional object in the three-dimensional object to create a three-dimensional object. Step starts with 0, step smaller than the number of steps. And let's calculate degree. You can start with the degree in the 4, but this is a little bit safer because of the floating points. When you rotate, there might be some missing parts or not enough not reaching points, so this is much better. For I is 0 and I is smaller than n I plus plus. Now we're gonna calculate every points from 0 to n. Let's start with calculating point 0x is equal to point I x length multiply cosinus degree and p0y will be this and p0z will be pi this time y. I will minus some numbers to move it up. Now we will add 3 more points, P1, P2 and P3, and this will be the next points x and y and z, next point x and y, and this point will be next point x and y, and this point will be I, and x this point also will be in the next angle, so we should add angle, and we should add increment here, increment here, also now we can add mesh data, vertex buffer, vertices, and p plus 0 is equal to p0 and one, two, three, 1, 2, 3. Now we can add texture coordinates. Actually we don't have texture here, but I want to show how you do this. Vertex buffer, text chord, okay, is equal to point F 0 and P0 point Y plus 35 multiply 45. You set normalize here and text vertex buffer text coordinates like this, and okay, now we should map the triangles. So we before this I want to add this also. You can add mesh data normals here, like by giving points. I just want to show this, and now mesh data index buffer indices ni plus 0 is equal to next point 0 and 1, 2 will be equal to if we back to the presentation, there is a plane 3D. We have P0, P2, P1 for the first triangle, P0, P3, P2 for the next triangle. So this will be P0, 2, and 1. And let's copy this. Three, 4, 5. This will be 0, 3, and 2. And MP is equal to MP plus 4. And NI is equal to NI plus 6. Or this is better. Plus 6. Now 4 is looping in this section, and this 4 is looping in this section. We close brackets here, and what we should do now, we should add mesh material source. With them we can add light material source, light material, let's change the color, light material source 1, and mesh data. Let's calculate the face normals. Face normals will be calculated. We set it true, and we can paint the mesh is here. Now we have mesh generated. Let's check this again. P1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 0, 1, 2, and 0, 2, 1, 0, 3, 2. Okay. And x coordinates, sinus, cosinus, same, degree, increments, desired increment. Okay. And let's back to this. what we need. What will happen when the form closes? We address two things, mesh and bitmap, so when we close we should free them. Mesh free and bitmap free. Let's check if we have errors. Oh, we have many errors here. We define step here. Where is the step? We didn't define step. Okay, let's define the step here. Start with 0. Vertex buffer. Okay, vertices. Text code, not text. One more error. Light material source 1. Also, let's check the light type. We have directional. It should be point light, so we can see our image very well. Now let's test this. Okay, we can draw objects here like this, and this, and this. Now we're gonna spin this with 36 steps. Okay, light is very shiny. Maybe we should move light or change the color to slate gray. Let's test another object. Generate. Yes, this is better. As you see, we are able to create any three-dimensional object by the mesh and in any steps. Let's test in 4 steps. 6, generate. 12, generate. 98. Yes. Clear, and let's start another drawing. Object like this. You can draw anything. Maximum number of lines is 100. Okay, this is the drawing that we do. Now that's all. I hope this example is very useful to you to generate any three-dimensional objects, so you can use any functions to create more complex, more objects or any objects on your 3D applications. Thank you for watching.